Staring at a skeletal equation is frustrating when atoms on one side don't match the other. Take the reaction between iron and steam. Here's that reaction written out. Fe plus H2O yields Fe3O4 plus H2. According to the law of conservation of mass, we cannot create or destroy atoms during this reaction. But right now, the numbers are mismatched. To fix this, we're going to follow the 7-step framework established in the official NCERT publication. This is the hit and trial method. Following these steps provides a repeatable checklist to resolve chemical imbalances logically. Step 1 is to write down the skeletal equation exactly as it appears in your notes. Next, draw a physical box around every chemical formula. This signifies that these internal numbers are now locked. Remember that the subscripts inside these boxes cannot be altered. You will only add coefficients to the outside. Step 2 is a full inventory, comparing atom counts on both sides. We have 1 iron atom left, 3 right. Hydrogen is balanced at 2 each, but oxygen is unbalanced, 1 on the left, 4 on the right. The inventory identifies the specific gaps we need to close, starting with the imbalances in iron and oxygen. Step 3 focuses on the compound with the highest atom count, Fe3O4. It has 4 oxygen atoms on the right. To balance the left side, we place a coefficient of 4 in front of the water box. Updating the tally shows we now have 4 oxygen atoms on the left, matching the 4 on the right. However, that coefficient applies to the entire molecule. We now have 8 hydrogen atoms on the reactant side, creating a new imbalance. In step 4, we add a coefficient of 4 to the hydrogen gas. 4 times 2 is 8, bringing the hydrogen back into alignment. Balancing is a repetitive process. Fixing one element often shifts the total count of another, requiring these step-by-step corrections. Step 5 addresses our final remaining element, iron. Our current count is 1 on the left and 3 on the right. We place a 3 in front of the iron atom on the reactant side. For step 6, we perform a final audit. 3 iron, 8 hydrogen, and 4 oxygen atoms are now accounted for on both sides of the arrow. Finally, step 7 requires physical state symbols, lowercase s for solid, G for gas, L for liquid, and AQ for aqueous solutions. This is the finished balanced result. 3 Fe solid plus 4 H2O gas yields Fe3O4 solid plus 4 H2 gas. Note that water is labeled as a gas. This indicates that for this reaction to occur, the iron must react with steam. These symbols ground the mathematical work in physical reality, defining the exact conditions needed for the experiment. You now have the full sequence. Define the boundaries, inventory the atoms, start with the heaviest compound, adjust for collateral shifts, verify the totals, and assign physical states. Let's apply this to a new problem. When magnesium ribbon burns in the air, it reacts with oxygen to produce a dazzling white flame and a white magnesium oxide powder. Here is the reaction in its skeletal form. Mg plus O2 yields MgO. Use these 7 steps to balance the equation yourself. Mastering this method provides the essential foundation for every complex interaction you will study in chemistry.